Okay, IBSL1, welcome to your extra day of reviewing. Well, your proper review day for the test on Thursday. We're first going to start with a couple of examples of solving some trigonometric equations, and then we're going to do closure notes afterwards. So, when I first look at this problem, some people might think like, well, they both have a sign, so I can factor them out, and you can try that, but it doesn't get you very far. The main thing you need to actually think is when you look at this, it's actually a quadratic in disguise. And here's what I mean by that. I could rewrite this, and we'll do it in green or something. It's similar to 2x squared plus 5x is equal to 3. So if this was the problem, you could get everything on one side. 2x squared plus 5x minus 3 is equal to 0. And then to try to solve by using your factoring techniques. You could use smoke and mirrors. You could guess and check it. So let's do that. But instead of using x, we'll keep sine of theta as basically our x. So this will be 2 sine squared theta plus 5 sine theta. But then I'll subtract 3 from both sides to get this set equal to 0. Now, you could do smoke and mirrors, but I think this one, because they're all prime numbers, is not too bad to kind of guess and check. I know it's going to start with 2 sine theta, and that'll be sine theta here, and that the two numbers here and here have to multiply to -3, so that's only like -3 and 1, or -1 and 3, and then they can swap places. And then everything has to add to that middle coefficient of 5. So I think it's this. It's like a plus 3 to give us a positive 6, and then you subtract 1 and gets it back down to 5. Yep. Then you would have to split both of these and set them equal to 0. So we get 2 sine theta minus 1 is equal to 0, and sine theta plus 3 is equal to 0. Now let's just start with this one and solve this, and then we'll get to the other one. If I try to get the sine by itself, I can add 1 and divide by 2. So sine of theta is equal to 1/2. Now, you should have an alarm bell that goes off in your head when you see that 1/2, because that's a side of a special right triangle. It's in the 30, 60, 90. Every single time, I encourage you guys to draw a circle and then try to figure out where the sine is equal to 1/2. Well, what are we doing? 0 to 2 pi. So I have to check around the entire circle. Sine is going to be 1/2 at pi over 6. Because that's a reference angle of 30 degrees. And then this side would be 1/2. And the sines are the heights, so that's 1/2 for that side. But it's not the only time that sine is positive 1/2 within the circle. Because if you flip that triangle over to the second quadrant, you get a matching triangle over here that also has a height of 1/2 for the triangle. So this would be 5 pi over 6. So for this right here, theta is equal to pi over 6 and 5 pi over 6. Now I have to solve this one and add those answers as well. So if I subtract -3 from both sides, and then I say sine of theta is equal to -3. Now, you guys, if I start to draw the unit circle and think about where the heights of the triangles are equal to -3, you guys, isn't this a unit circle? So the deepest the sine can get would be here when it is equal to -1. But sine can't get past that -1. It can't ever really get to -3. So this part of the problem is no solution. But that doesn't mean the whole problem is no solution. It just means that my answers over here are the answers to the problem. Pi over 6 and 5 pi over 6. Next up, a double angle. Solve sine of 2x equals root 2 over 2 for 0 to 2 pi. Okay. I struggle with how to do this one for you guys because we haven't learned about graphing sinusoids yet. So, okay, let's just talk about it. Let's just pretend this was just an x and solve. Well, if I think on the unit circle, that didn't go very well. on the unit circle of where sine is equal to root 2 over 2. Root 2 over 2 is part of a special right triangle. It's a 45, 45, 90. So that would be pi over 4. And then also here matching in the second quadrant of 3 pi over 4. Now, that's just the regular theta, that it's like it would be pi over 4 and then around to 3 pi over 4 as well. But that's pretending that this part was just an x. So we have to say that 2x is equal to pi over 4, and 2x is also equal to 3 pi over 4. So when you solve those, to solve for x, you get x is equal to pi over 8, because you divide both sides by 2, and then you get x is equal to 3 pi over 8. Now, if you made it that far, that's awesome. Those are pretty much the answers. But you need to realize that because the 2 is making like the radians happen twice as fast, and we're going all the way around from 0 to 2 pi, it's kind of like you have to find all the values between 0 and 4 pi and then divide them by 2 to find your answers, because there's actually going to be 4 solutions to this. So if you think about that theta, you know, I'll use a different color, going around the circle, and it's going twice as fast. When theta goes from 0 to 2 pi, it actually goes from 0 to 4 pi because they're getting doubled each time. So it's like, you know, from 0 to pi, it goes once around, and then from another 2 pi is a whole another way around. So we actually need to figure out where from 0 to 4 pi it hits root 2 over 2. So the way you can do that is just take these values and add 2 pi to them. So let's do a little sidebar. 3 pi over 4 plus, well, 2 pi as pi over 4s would be 8 pi over 4. So this would be like 11 pi over 4. And then pi over 4, the other one, plus 8 pi over 4 would be 9 pi over 4. So in addition to these answers, pi over 8 and 3 pi over 8, we also have to say 2x is going to be equal to 11 pi over 4, and 2x is going to be equal to 9 pi over 4. So divide by 2 on both sides. This is 11 pi over 8 and 9 pi over 8. So maybe I'll get rid of my boxes and do one final answer. X is equal to pi over 8, 3 pi over 8. I'm going to try and go in order. Yeah, 9 pi over 8, and 11 pi over 8. That's it. Those are the answers. Later on, when we start to learn about, like, you know, these curves, like going like this, you can think of this as like compressing it horizontally by a factor of 2, which would mean you'd actually have like 2 of these in between. But don't think about that too much right now. Just think about like the theta going twice as fast around the circle. Here's our closure notes. Here's everything you could be tested on Thursday. You should know how to change radians into degrees and vice versa. Take a degree and turn it into a radian. We also did a little bit of areas of sectors, those pizza slices, and lengths of arcs. You can use the formulas for those. They might even be in your formula packet. I don't know. I just use proportions, but either way, it's fine. In the unit circle, you will be expected to find exact values of sine, cosine, and tangent, or know what sine and cosine and tangent represent. You should know about the relationship of all the quadrants, about, you know, sine is negative in quadrant 3 and 4, and cosine is negative in quadrant 2 and 3. You can use the all students take calculus if you want, but I don't always use that mnemonic. Know your special right triangles, backwards and forwards, the sides of the 30, 60, 90, and the 45, 45, 90. And know how to find those exact values of, like, you know, root 3 over 2, or root 2 over 2, or 1/2, or 1, or 0. Do not report out a decimal anywhere on this test. In fact, no graphing calculators whatsoever on this test. Just you, the formula packet, pencil, paper, and your brain. Some of the last things we've been doing are trig identities. We've definitely done the Pythagorean, sine squared plus cosine squared equals 1, and we did some of the double angle formulas. Remember, there's just one double angle formula for sine, but for cosine, there are 3 of them. When you use each one is kind of up to you about what's going to make the algebra easier on you. Lastly, you will be asked to solve some basic trig equations. You should be able to work backwards on the unit circle and to figure out like exact values of sine, cosine, and tangent. Factoring has come up sometimes when a trigonometric is in disguise as a quadratic, and be able to find multiple answers over a domain. Like on this problem right here, we found 4 answers over the domain 0 to 2 pi. Okay, you guys, happy studying. All the solutions are on the attached reviews. Good luck.